Broadcasting from Boston, Massachusetts, the ARC Digital Transformation Viewpoints podcast is the only podcast dedicated to all things related to digital transformation in energy, industrial, and critical infrastructure applications. The podcast is the creation of the ARC Advisory Group Digital Transformation Practice. ARC advises leading companies on technology trends and market dynamics that affect their business. To engage further, please like and share our podcasts or reach out directly on Twitter at ARC_advisory, or please go to our website at arcweb.com. Hello and welcome back to the ARC Digital Transformation Podcast. My name is Larry O'Brien. I'm Vice President of Research at ARC Advisory Group, and we are here today to talk about OPC UA and the role of security in OPC UA. And I have with me today Randy Armstrong of the OPC Foundation. Good afternoon, Randy. How you doing?
Good day. I'm glad to be here.
Yeah, I should say good morning because you're in Japan right now. So we appreciate you coming on with the time difference here. I know it's probably pretty early in the morning there. We want to talk about security in the context of OPC UA. And if you are in the manufacturing sector or any of the process industries or hybrid or discrete industries even, I think OPC UA is used pretty much universally across all the manufacturing industries. But Randy, I would like to take a minute right now and maybe you could describe to us what is OPC UA and the OPC Foundation, and just briefly your role within OPC Foundation.
Well, if you go back to the starts of OPC, it was developed back in the mid 90s when a lot of vendors were frustrated because of the huge cost of writing custom drivers for every possible piece of equipment you could see on a factory floor. And as if anybody who's been in a factory floor knows that you're talking thousands upon thousands of unique devices that could show up.
Right.
And so that was the genesis of the original OPC, was we needed to standardize the communication between the HMIs and the SCADA and the equipment on the factory floor. And this was a immediate success. People started implementing OPC both sides, and it became a de facto standard in industrial automation. But the original OPC was based on a Windows technology, and that technology was being deprecated by Microsoft. It was had numerous issues that
was object linking and embedding, right?
Yeah, well, that was the original name, but the more common name is DCOM. And it basically the lifetime of that particular protocol was coming up, and so we realized we needed to rethink OPC for the future. We needed to come up with a platform that would make it relevant moving forward, and that was the basis for the OPC UA effort. And when we sat down and we said, okay, if we're going to define our path forward, what are the key requirements that we wanted to do? And the two key requirements that we had was, one was to create a much more generic information modeling framework to allow people to focus on information rather than tags, and the other was security. We wanted to have a protocol that a standard that incorporated security as a first-class concept from the beginning. Every aspect of the specification is analyzed in terms of its impact on security, and has to be able to follow the conventions and the requirements that we've laid out for the overall framework. So by doing this, we've been moving forward with a standard, or developed a standard has a very cohesive, holistic view of security that shows up at different levels in the implementations.
Okay, so this isn't something that you guys are bolting on to OPC UA. This is security is something that you've been thinking about pretty much all along, and it's been kind of baked in for quite a while. Right?
Yes, from the beginning, and that's one of the most important things. A lot of times when people develop standards, security is an afterthought. Oh, we'll just turn on TLS and we're done.
Right. And that's part of why I wanted to have this call with you today is because I think when most people think about your OPC UA, security is kind of an afterthought, or if they think about it at all. But there is actually quite a bit of security that's baked in here, and it's been baked in for a long time, since basically the beginning of OPC UA, right?
Yes.
So what I would like to do is kind of go through these different layers of security, because you do some interesting things with security, and they're things that we don't talk a lot about always, in the manufacturing or industrial or critical infrastructure sector with regards to security. So if you don't mind, I'd like to just go through that with you right now. And I guess the first thing we want to talk about is encryption capabilities. I think most people probably know in general terms what encryption is, but I'd like you to talk about why encryption is important to OPC UA and the various levels of encryption that are available within OPC UA.
Yeah, it's important. The encryption works at the lowest level when you're talking about getting a message across a network. And encryption ensures privacy, but encryption is only half of the problem. You need to have something else that ensures integrity, something that makes sure that the message can't be changed when it goes across a network. And in many industrial applications, the integrity aspect of these algorithms is actually more important than the encryption, because they need to make sure that bad actors can't be inserting or modifying messages as they're flowing through the network, and that's actually more important than simply making sure that they can't see them. But with UA, we've got these. What we do is we create these different what we call security profiles that define suites of algorithms to apply the encryption and integrity transformations to the messages as they go across the wire. And the purpose of these profiles is to make sure that there's a limited number of targets that people could shoot at when they're developing their applications. So you don't have this huge laundry list of possible algorithms that you could pick, and you're scratching your head and you don't know which one is good. No, you go to the OPC Foundation site and they say, okay, here's 4 different profiles. These 2 are deprecated that you might need for backward compatibility with old applications, but here's the 2 that you got to implement now because they're the state-of-the-art secure technology. And here's a couple more which are coming down which will likely be the standard in the future, but they're not there yet. And that's how we publish the encryption and integrity algorithms that are needed for OPC UA.
Okay. Can you explain a little bit more about these profiles and what they are and what they do?
Well, the profiles, like you said, they're just they're bundles of algorithms that we put together, and we put them together because they fit together and they make sense. And then because they're a bundle, they now become a package that product developers can target. So they don't need to have this incredibly complex test matrix where they have to test every combination of algorithm with every other combination of algorithm. They only need to test these discrete profiles.
Okay, good. That's what I was going for there. It's more on the development side, but I think that's important too, right? And it's what we're talking about today is multi-dimensional too, right? It's not just cybersecurity for the end users of OPC compatible products, but also cybersecurity resources for OPC product developers. So that's important too.
I'd also like to point out is the profiles also make it easier for users of OPC UA products, because now they've got basically a simple word to to compare products to make sure that they support what they need. So you can go and take a look at the product documentation. If you know you don't want to have any deprecated protocols in your network, you can quickly go and look at the product feature list, and you'll see these profiles, and I'll tell you which products that you will meet your requirements.
Okay. And OPC UA also has authentication capabilities. Let's talk a little bit about that and your use of certificates and the public key infrastructure, PKI, and other advanced authentication capabilities. But this to me is a topic that's coming up a lot more now. As we start talking more and more about things like zero trust and things like that. Let's talk about your authentication capabilities.
Certainly. One of the things with UA is we've got two layers of authentication, and this is not the most common paradigm. Where what we realize is that, especially in industrial automation, it's not enough to have the credentials. You need to be able to lock those credentials to a particular host or particular application. So if you have an engineer in your factory and that engineer is authorized to make changes to your operating system, you only want that engineer to be doing it from an application that you trust that's running on one of your computers. You don't want that engineer pulling out their iPad, downloading some OPC client and connecting to your PLC. That shouldn't be allowed, even if that engineer has the credentials, has the username and password. So what we've built into the OPC UA infrastructure is this concept of application authentication. So every application that's installed on a particular node has a unique identifier and has a certificate assigned to it. And it will be configured to only allow communication with some finite number of other applications. And it's up to the administrators to decide who's allowed to trust who. And they have very fine-grained controls. So you can have a cell on a factory floor with 10 machines, and those 10 machines would all be configured to talk to each other, but nobody else. And this is going to be independent of the user credentials, which may determine what access somebody has when they're accessing the machine. So it's really that two layers of authentication that is very important with UA. In terms of how do we do the application authentication, as you mentioned, this is all based on PKI, leveraging off the PKI infrastructure that exists out there, and to distribute and manage certificates.
Yeah, which is highly secure, right? PKI is very solid, I think. And you want to say a few words about your support of PKI and why you think, why you chose to support that kind of an infrastructure?
Well, PKI is the industry standard in terms of how do you one of the problems with any sort of security is both sides need to agree on a secret that is used for these algorithms, and you need a way to distribute these secrets, and PKI is simply the industry standard mechanism for distributing this information, the information needed to negotiate these secrets that kick off this entire process. Now, PKI itself is a generic framework, and it can be strong or weak depending on the algorithms that you're actually using. So simply saying PKI itself is not strong, but PKI with the latest RSA certificates is strong. PKI with using ECC certificates is strong, but PKI with 128-bit certificates is not. So just to clarify that particular point.
Yeah. No, I think it's good to be talking about this stuff. And I think we're going to be talking about it more and more in industry and infrastructure too. I don't think there's a lot of places right now where you can go to find, to discuss, PKI and different encryption technologies and RSA, as it relates to automation. But people are starting to talk more about these things, like I said, as these topics really come to the forefront. People really, yeah.
I was going to say, what I think is very important is that for the end user, the consumer of these products, that the software vendors need to get to the point where they provide software that implements these solutions in a way that doesn't require the end users to become experts on these things. that
I
what
agree.
what the end user, all the end user needs to understand about OPC UA systems is that you can't two applications can't talk to each other unless they trust each other. How you set them up to trust each other should be handled by the software that they're using.
Mm-hmm.
And now, if that software is using PKI, which it will under the hood, that all should be hidden from the end user.
Yeah, so we're not necessarily making their lives more difficult, but this is built in, like you said, under the hood.
Yes.
So we're making it more secure without putting more work in their lap.
Well, and that's the only way to ensure security, because the reality is, if somebody has a job to get done, and if the security gets in the way of getting that job done, they will turn off security and create a vulnerability, because having a working factory is a higher priority than having a absolutely secure one. And this is the reality of the industry, which again, this has been a personal focus of mine for a long time, is how do we make security manageable to the point where end users can just turn it on and manage it without feeling it's interfering with their work.
Mm-hmm. Yeah, that's definitely my philosophy too. We need to automate everything we can automate and bake in everything we can bake in, in terms of security, because the users just don't have the resources to deal with a lot of this stuff. And like you said, if they do feel that this is getting in the way of production, or this is going to somehow result in some kind of unplanned downtime, they'll just turn it off. Because that is the sort of prime directive of manufacturing, right? Is to avoid unplanned downtime, keep things running. But I think it's important too to realize what's under the hood too,
right?
And to understand that. And that's what we want to do today, is sort of bring this out, tell people, this is what you are doing under the hood. This is why it's important. And this is the kind of stuff that end users should really be looking for in their automation solutions. And certainly, with kind of a standard, an industry de facto standard technology like OPC, should have these kinds of security functions built in. Let's go a little bit deeper as we're, going up these layers here. We started with encryption. We talked a little bit about OPC authentication capabilities. And you also support some critical auditing functions, right? Like system logs and audit trails. Let's talk a little bit about that.
Yeah, the logging function, part of when we said we bake in security into every aspect, is every security sensitive operation in UA produces what we call as an audit event, and these audit events have numerous tracking information that can allow you to correlate calls across multiple UA applications. So if a client calls server B and then server B calls server C, then there'll be a trail of breadcrumbs to allow you to link the events from the different applications together. So that is how we sort of put it in there. And the notion is that whenever we're doing something, one of the requirements is, okay, where are your audit events, to make sure that these things are being produced. Now, how these audit events are actually reported or logged is going to be up to the applications themselves, but the infrastructure is in there in the SDKs and the software to produce these events in the first place, and then they can be captured and then incorporated into existing software that's designed to analyze these things and look for potential issues and trace down sources of problems.
Yep, and anybody who's worked with cybersecurity knows that system logs are really important, especially if you're trying to do some forensics and, investigate a cybersecurity incident or some kind of an abnormal situation. That's really important.
Yep.
I think another thing we wanted to talk about too was centralized management of the security configuration, right? Yes. And that is, I think, you consider that to be kind of a key differentiator in terms of your security scheme. Let's talk about that.
Yeah, as I mentioned earlier, one of the things that the OPC UA is really pushing software vendors towards is providing a unified solution that hides a lot of the details of security from the end user. And part of this is developing APIs that every application could implement to interface with the PKI infrastructure. So this was needed because there is no standard PKI infrastructure out there. There's lots of different vendor specific solutions. And so if a particular factory decided to put down a Microsoft domain controller in there, they could use that for their PKI, but somebody else is using something that's Linux based, and they're doing something completely different. So which makes it impossible to build in support for PKI into every application. So what we did with UA said, okay, we will put an API, a layer between the OPC, the applications running on the devices and the HMIs, and the actual PKI. And all the applications can be designed to work with the OPC UA interface, and then third-party products can be produced that would interface with the actual PKI systems. So what you do by doing this is we make it possible to have sort of plug and play interoperability with these different PKI systems. And that I do see as being an important value add of OPC UA. And it's taken some time for the third-party products to be developed. There's at least 3 or 4 being coming, either they're on the market now or they're coming down the pipe, and a lot of people they're starting to build out their larger OPC UA application systems with a lot more OPC UA applications, and then they're realizing how essential these pieces are, which is of course providing a market push for getting these pieces finished. But ultimately, what you'll end up with is a factory where you have a bunch of OPC UA devices and other HMI SCADA all deployed, and they're all going to be communicating with a special service also running in your factory that is managing all their PKI. And once you set everything up properly, certificates should automatically renewed. Trust lists can be renewed. You can prevent accidental holes being opened by technicians doing debugging by automatically updating trust lists, and numerous other tasks which can be taken care of, and just take care of the grunge work of security management, and make it much more feasible to have a system running constantly with full security enabled.
Yeah, that is really powerful, and it does take out a lot of that grunt work, like you said. It sounds great. When do you think these will be available?
Well, they are. Some of them are available now, and
are available now. Okay.
And we're for the last couple of years, vendors that have been coming to OPC Foundation interoperability events have been coming with products that support interactions with the we call it a GDS. That's the name of the service.
What does that stand for?
It stands for Global Discovery Service, because it also doubles as a registry for all of your UA applications. So if you wanted to find something on the network, you can go there as well as handling the PKI. So so
that's really handy, and it's all baked in too. So it's not like you have to purchase some kind of expensive new zero trust security solution to manage all this stuff. It's already in there.
It's there, but the important thing is that if somebody has if a vendor right now already has some sophisticated PKI management solution, they can simply bolt on the API in front of their system, and then they could then immediately be able to talk to all these UA devices. So this is intended to supplement that market for those kinds of systems, not replace it.
Okay. Excellent. Well, let's expand on that a little bit. You talked about some of your events. You participated in Pwn to Own recently, and you told me about this. Let's talk about some of the things that you're doing to keep your applications secure, and that includes opening them up to testing at different events and so forth. Tell me a little bit about Pwn to Own.
Yeah, Pwn to Own is an event that was held 2 years ago before COVID. Seems like ages ago.
Eternity, yeah.
It originally started as a consumer electronics thing, where people this company would pay hackers to go after consumer electronics, and based on the exploits that they would find, they would get paid cash, and depending on how serious the exploit was, they would get paid more. So and it's become a huge resource for a lot of the major commercial electronics companies and commercial software companies, because it allows them to find problems in their software and get it fixed before they're actually exploited in the wild.
Mm-hmm.
Well, 2 years ago they decided to expand this to take a look at industrial automation devices. So they had a number of industrial automation devices, as well as they had a specific category for OPC UA. And so they put the bounties on, and people attacked it. They found some minor issues, which were fixed fairly quickly. But for the most part, they didn't find anything major. This time in January, they're planning another go at it with more products, and we've asked them to specifically focus on the authentication aspect. I talked a lot about the application authentication earlier, so they're putting we asked them to put the biggest bounty on actually breaking that, because we saw that as sort of the weakest link. If somebody could break that authentication, then a lot of the security stuff. So if there's problems there, we want to find them out as soon as possible. So we'll see that we'll see if anything's found out, anything's discovered with that. But for us, it's a very positive thing, because we very much believe that the sooner these things are found, and if they're found publicly, the better.
Yeah, I agree with you. That's a great thing to do. Yeah.
Yeah. So even though it has a potential to sound like it will create a potential for a black eye in the short term, because somebody screwed up. But
but it's better to go into this and really address any of those vulnerabilities that might exist. And they sound like a pretty talented group of people that will be trying to uncover those vulnerabilities. So
yeah, there's an entire industry out there of people who spend their lives trying to hack stuff nowadays.
I hate to call them hackers. I think that term's a little overused, but let's call them vulnerability discoverers, I guess. But you've done some other stuff too recently. You did a security analysis with the German Office for Information Security, right?
Yes, they periodically will review whenever we release new version of the specification. They will do a detailed review of the specs and identify issues that they think we need to address. And so we get a whole long list of deficiencies, which range from problems with wording to missing features to things that need to be better explained. And so we had another round of that in January to March this year, and and all of this feedback's been incorporated into the 1.05 versions that are being released right now.
Okay.
But it's a very valuable effort, but it just sort of illustrates how critical OPC UA is, because you have these agencies investing this time and doing this kind of detailed analysis and providing the feedback. And of course, the OPC Foundation really appreciates that. We make every effort to make sure that their concerns are noted and judged. But for the most part, it's all the comments. There's really no major show-stopping issues that come up. They're generally very happy with how the security posture of the security features in OPC UA, and it's just making the devil's in the details sometimes and making sure that those are all properly specified.
Mm-hmm. And well, I think that's great to keep things open, keep things transparent. To me, the most secure offerings out there are the ones that have this level of transparency and openness and are willing to subject themselves to review, to outside sources. Which I guess is a good thing about OPC Foundation, right? I mean, it's like I said, it's an industry association that's been around for a long, long time, and is basically a de facto standard in the industry right now. So that kind of openness, I think, is reflected all the way down into your organization too.
Well, yeah, I guess if you want to, OPC is now an IEC standard, so that's sort of OPC UA.
It is an IEC standard.
So it's not just a de facto standard now; it is a standard.
Oh, I apologize for that. I probably should have known that. So what standard does that fall under with the IEC now?
It's I believe it's their 65,000 series. I can't remember.
Yeah, 65. Yeah.
It's 65,251, I believe, is the official.
Yeah, I'm probably showing my age because I was around when OPC first got started. So it is in fact, a standard technology. Correction there. Any other activities or updates to OPC from a cybersecurity perspective that you want to talk about?
Well, one of the initiatives that we're working on now, we're in the final stages before the release, is one of the problems in the industry that our members brought forward is this entire issue of counterfeit devices, where factory owners would quite literally have PLCs with Siemens labels running on them for years, only to find out when they have a problem that they're not actually Siemens devices.
Mm-hmm.
And so we've been developing a standard in conjunction with some of the bigger device makers to provide factory owners with a way to authenticate the origin of their devices. And we're tying this all into the existing OPC UA security infrastructure to move towards a mechanism where you can plug in a device and it will be authenticated as a legitimate device and then automatically configured to run on the network.
Okay.
And so that's it's sort of an extension to our security mechanisms that we're already developing.
Well, we'll look forward to talking about that once that is available. Anything else we want to mention here? We do want to mention resources, right? There are a lot of resources there for OPC. If you want to go to opcfoundation.org/security, there's a pretty comprehensive security page there, and also that YouTube presentation that you gave that goes into a lot of these topics that we just discussed here today in a lot more detail. That's a really good presentation. I watched that recently. Any other resources we need to bring out there?
Yeah, no, I think those, in terms of OPC specific ones, those are the major ones. Now periodically, OPC Foundation has their OPC days where we present different topics. Sometimes we'll have topics specifically related to security or how security is used. Those events happen every few months.
Oh, and then just getting back to your IEC, that is IEC 62541 standard.
Yes.
That OPC UA is. Yeah. So, forgive me for dropping the ball there earlier. Well, this has been a great discussion. I look forward to talking about this some more, as these new developments come into focus here with OPC Foundation. Again, I want to thank you for joining us today. I think this has been a really valuable discussion. Not enough people know about what goes on under the hood with this kind of stuff. So I think it's very valuable to bring this kind of discussion out and just let people know what's happening. So what is your title at OPC Foundation too? Because I didn't mention that at the beginning.
Well, I have a lot of hats within the OPC Foundation. For this particular discussion, I'm the chair of the OPC UA working group.
Okay, chair of the OPC UA working group. Security working group, right?
Yes.
So we have been talking today to Randy Armstrong, the chair of the OPC UA security working group at the OPC Foundation. And thanks again, Randy. It's been a great discussion on the ins and outs of OPC UA security, some of the really cool things you're doing to address cybersecurity issues in industry and manufacturing with your many applications. If you want to go find out more about OPC, again, go to opcfoundation.org/security. If you want to find out about security, or they have just about everything else there you'd want to know about OPC Foundation. Again, I want to thank you for joining us here on the ARC Digital Transformation Podcast. We'll join you again soon, and thanks for listening.